All right, in this lesson, we are getting an introduction to the logarithmic function. And so we're going to start with this warm-up, which is an exponential equation, and it's asking 2 to the x power equals 100, and we're trying to figure out what x is. And so we could guess and check knowing that 2 to the 5th is 32, 2 to the 6th would then be 64, 2 to the 7th would then be 128. So the 100 would fall somewhere between 64 and 128. So we know x is not a whole number. So somewhere between 6 and 7. So that's the best we could do without solving. Okay, and so in order to solve this, what we need is an inverse function that undoes raising a base to an exponent. And so there is a function that does this, and it's called the logarithmic function. And so this is going to help us give the desired exponent. And so it's defined to be the inverse of the exponential function. And so what we actually do is just convert between the two forms. So for example, if I have b, a base of b raised to the x power equals some answer a, the logarithmic form would have the same base, but it would take the output and give you the input, which in this case is the exponent. Okay, and so to convert between the forms, the two things you want to keep in mind is that your base for your exponent is the base for your logarithmic function. That is a subscript. You want to make sure that is small and below the word log, because this is a function. Okay, the other thing you need to know is your input, your exponent, becomes your output of the log, and your output of the exponential becomes the input of your log. So something that's kind of helpful when you're converting between the forms is some people like to make a loop. Okay, and so starting with the base, b to the x power equals a. So as you convert, you can make that loop, b to the x equals a, and that same thing goes in reverse. Base b, so log base b of a equals x. And so we're just going to practice converting between these two forms. Okay, so for example, I have 9 as my base. Notice 9 is my base. 2 was my exponent. Now it's my output. And then my output becomes my input. Okay, and so if you're wanting to make the loop, it would be log base 9 of 81 equals 2. And sometimes they're lazy about using the parentheses. I always like to use parentheses, and so if you want to add your own, you can. If you don't want to include them, you don't have to. That's only when there's only one argument. If you have more than one argument of your log, you will need parentheses. Okay, so for this next one, it's log base 2 of 8 equals 3. Log base 2 of 8 equals 3. This next one, it's log base 3 of 243 equals 5. Okay, here we have log base 25 of 5 equals 1/2. Okay, this next one we have log base 10 of 10,000 equals 4. Log base 10 of 10,000 equals 4. And so here, log base 10 is actually a special log called common log. So anytime you have a base of 10, it's called common log. And so with common log, you may have seen this button in your calculator. They don't write the 10. And so it's understood, just like when we talk about cube root, we have to have an index of 3 for our radical. But when we talk about square root, we don't put that 2. It's understood. Square root's kind of like the original radical. And so that's how log base 10 is. And so if you don't see a subscript for the log, it's automatically base 10. And so that's going to be important because they don't usually write the 10. So if you don't see the 10, you have to write it in yourself. Okay, and so I'm going to rewrite that answer that we just wrote using log 10,000 and then the equals 4. Okay, and then this next example, we have base 6, so log base 6 of 1/6 equals -1. And then just in general, if I have letters, you can still do the same thing. So log base A of C equals B. Log base A of C equals B. Okay, and like I mentioned, I always write the parentheses, but most of the time they kind of leave them off. And so don't let that confuse you. If you don't want to write the parentheses, you don't have to. But if you want to, you can. All right, so going the other direction, converting from log to exponential is actually a little bit easier because you have a way to check your work. So looking at this next example, we have 8 to the second power equals 64, which we know is a true statement. Here we have 9 to the first power equals 9, which again we know is true. 2 to the 9th power equals 512, or 512. Here we have 8 to the 1/3 power equals 2. And again, we can check that because we know 8 to the 1/3 power is the same thing as cube root of 8, which we also know is 2. Okay, for this next one, 4 to the -2 power equals 1/16. And so if we were checking that, 4 to the -2, anytime you have a negative exponent, that means 4 to the +2 is on bottom, which we know is 16, so 1/16. B to the 0 power equals 1, which is also true because anything raised to the 0 power is 1. That's a property of exponents. And so this rule right here, log of 1 equals 0, will be a property that we talk about for logs. Anytime you put 1 as your input, 0 will be your output. Okay, another important log, we've talked about common log, but another important log we need to talk about is natural log. And so the exponential base that's most commonly found in nature is the natural base e. And so e is approximately 2.178. It doesn't end there. It's kind of like pi. So just like we know pi is approximately 3.14, e is also a famous constant. So you can't use e as a variable, which is why you don't usually see e written as a variable, because it's a number. It's a famous constant. And it actually comes from Euler, and that's why we use the e. And so for common log, we just drop the base altogether. We don't write the base. And so if you don't see a base, you write 10. For log base e, we replace it with ln. A lot of people think that's an in. It's ln for natural log. And so when we're converting, you're not going to write log base e. That's not standard. You would write ln instead. Okay, so for this next example, if we're converting to log, we have log base e of m equals 2. So log base e of m equals 2. And anytime you're tempted to write log base e, you write ln instead for your final answer. Okay, here we have log base e of 4 equals y. So I'm not writing log base e, I'm writing ln. Here we have common log, log base 10 of 1,000 equals 3. And so anytime you're tempted to write log base 10, don't write a subscript at all. Okay, here we're back to e to the n. So log base e of n equals pi. So log base e is ln of n equals pi. Okay, going the opposite direction, here we have natural log. So if you want to fill in the e to the z power equals 8. E to the z power equals 8. Here, filling in the e to the first power equals 1, which makes sense. And then here, fill in the 10. 10 to the first power equals 10. And then here, e to the 0 power equals 1. And so this last column, you have a good way to check your work because these are properties of exponential, which are now going to be properties of their corresponding log functions. Okay, so next, now that we know how to convert, we're going to talk about how to evaluate these logs without a calculator. Okay, and so here, I like to put either a box or like an n, some kind of variable. We're trying to figure out log base 10. There's no subscript, so I'm going to write it in. We're trying to figure out log base 10 of 1 million. Okay, and so if I were to convert this, it would be 10 to some number equals 1 million. 10 to some unknown number equals 1 million. And so how many zeros there are, which in this case there's 6, tells you what power of 10 you have. So here you would answer 6 as your final answer. And so just to prove that to you using a calculator, log 1 million equals 6. Okay, here we have log invisible base 10 of 10 equals something. And so if I convert, I have 10 to some power equals 10. We're trying to figure out what that number is, and of course we know that number is 1. And so you would answer 1 for this. Again, I can verify that in my calculator, which you won't have a calculator for these kinds of questions. And so I'm just trying to prove it to you in the notes. 10, oh, clear. Log 10 is 1. Okay, and so for this next one, we're trying to figure out log base 4 of 16. And so if I convert to exponential, 4 to what power equals 16? And of course we know that is 2, and so our answer would be 2. Here we're trying to figure out log base 8 of 1. So 8 to some power equals 1. And so we know that power has to be 0. And so your answer for this problem is 0. So on this next problem, we're trying to figure out log base 5 of 625. So we convert 5 to some power equals 625. And that would be 5 to the 4th power. And so your answer would be 4. Okay, getting a little bit trickier here. We're trying to figure out log base 25 of 5. So 25 to some power equals 5. 25 to some power equals 5. Well, in my head, I know that square root of 25 is equal to 5. And we know square root is the same thing as a 1/2 power. And so that means this answer is 1/2. Okay, similar problem here. We're trying to figure out log base 8 of 2. So 8 to some power equals 2. And so once again, I know the cube root of 8 is 2. And cube root is the same as a 1/3 power. And so this answer is 1/3. All right, here we're trying to figure out log base 8 of 8 to the 999th power. And they usually put these kinds of questions on calculator tests to see if you really know the principle, because I don't think the calculator can handle this kind of input. So if I was doing log base 8 of 8 to the 999th power, it's an overflow error. So even having a calculator wouldn't help you. And so that's why it's important to know how to do it without one. So if I convert it, 8 to some power equals 8 to the 999th. 8 to some power equals 8 to the 999th. And so it tells you the answer. You would just fill in that blank with 999. Okay, and so that's actually a property of logs. If your base of your log is the same as the base of an exponent inside the log, they cancel out and just leave you with whatever that exponent is. We're going to talk about that. The similar situation happens in reverse. So here I have 2 to log base 2 of 16. So let's figure out what this log base 2 of 16 is. So down here, I need to figure out what that number is. Okay. And so 2 to some power gives me 16. And we know that number would be 4. Okay, so I can replace this whole box with a 4. And so now my problem turns into 2 to the 4th, which gives me back to 16. Okay, and so you're kind of seeing that property happen here. We have base 2 of the exponential, and we have log base 2 canceling out, leaving us with that 16. Okay, that's called the inverse property. And so here, I'm going to fill those in first. Log base b with exponential base b just gives you x. Exponential base b raised to the log base b just cancels out and gives you x. Another property we've been looking at is b to the 0 power is always 1. So that means log base b of 1 will always give you 0. Just think of converting. Okay, and then if you have log base b and then just b, that would just give you 1 because b to the first power gives you b. Okay, and so these are true for common log too. Anytime you put 1 in, you get 0. Anytime you put 10, so here 10 would give us 1. And then this is base 10 canceling with base 10, giving us x. This is base e, but we're still inputting 1, so we're getting 0. Here we have base e, and then our output is e, so the exponent was 1. Here, base e and base e are canceling. Okay, so same properties as if these were a b. This b is just some general base. That b could be 10. That b could be e. Could be anything. So we just kind of explicitly wrote them out here. These are especially helpful for PSAT and SAT.